minutos. E aí pessoal, tudo bom? Então vamos começar aqui uma live sobre o Astra, que é um satélite que vai ser lançado hoje ali pela NASA por um foguete de pequeno porte. E nós vamos aqui no Astronaut Live iniciar aqui essa primeira transmissão ao vivo de um lançamento de um foguete. Sejam bem-vindos aqui ao canal Astrolive. Se você não é inscrito aqui do canal, se inscreva aqui no canal, né? Astronaut Live, que vamos sempre estar fazendo lives sobre lançamentos de foguetes e tudo mais. Caso você queira fazer uma pergunta aqui, faça uma pergunta, diga de onde você é, qual região você está, e nós vamos aqui transmitir. Falta apenas 6 minutos para começar aqui o lançamento desse foguete. Tá? Vou dar mais informações para vocês sobre esse lançamento. Gostaria que vocês se inscrevessem aqui no canal Astronaut Live, né? Compartilhe também essa live para mais pessoas, assim nós podemos crescer o canal, ok? Então falta exatamente, segundo aqui as informações que nós temos aqui, faltam 2 minutos para começar a transmissão dessa live, né? Que é lá pela Space Flight Now, que vai transmitir esse lançamento desse foguete, né? Aqui também está dizendo que a Astra iniciará a campanha de 3 lançamentos com satélites de pesquisa de furacões da NASA. Então, esses satélites serão para monitoramento de furacões, que acontece muito ali nos Estados Unidos, ok? Então, esse lançamento vai ser um lançamento inicial. Vão ser 3 lançamentos no total. 3 lançamentos no total. E segundo as informações aqui, está dizendo que o Rocket 3.3, esse foguete da Astra, né, número LV0010, fica em sua plataforma de lançamento na estação da Força Espacial de Cabo Canaveral, lá na Flórida. E antes do lançamento na missão TROPICS da NASA, certo? Esse Astra, que é o nome do foguete, está se preparando para lançar aí a primeira das 3 missões dedicadas para a NASA, ok? Caso você queira acompanhar, na descrição aí tem o resumo completo do que está, o que é esta missão, ok? Sejam bem-vindos, Lumulura, bom dia. Ele é nosso aqui administrador do canal, o Lumulura. Você também pode deixar aí um comentário, se você quiser, dizendo se você é inscrito novo, se você está aqui pela primeira vez. E vamos continuar aqui a nossa transmissão. Eu imagino que já vai iniciar a transmissão, né? Falta, vou pôr aqui certinho, já estamos esperando, já é meio-dia, horário aqui de Brasília. E ainda essas informações você pode contar aqui que, segundo aqui a Astra, né, esse foguete que está lançando é um lançamento diferenciado devido ao tamanho desses satélites. São satélites muito pequenos, máximo 5 kg de carga, então para colocar no espaço. Então o foguete da Astra não vai fazer muito esforço assim para colocar esse foguete em órbita. Antigamente, antes dessa nova tecnologia, era necessário um satélite maior, né, do tamanho de uma geladeira ou algo assim, para a mesma tecnologia que tem hoje nesse satélite minúsculo, ou seja, de 5, tamanho de uma caixa de sapato. Esse satélite agora que vai ser lançado, vai ser 2 satélites. E aqui diz que vai ser 6 satélites no total, e agora vai lançar 2. Né? Vai implantar 6 satélites de pesquisa de furacões do tamanho de uma caixa de sapato. Olha que interessante. Ajudando a abrir um novo paradigma de missões científicas mais arriscadas, mas menos caras. Ou seja, vai ser mais arriscado, mas com um preço bem mais baixo. Mas mesmo assim, o valor total dessas 6 satélites vai ficar em torno de 32 milhões de dólares. É pequeno, mas é muito grande o valor ainda, né, galera? Vai ser um valor de 32 milhões de dólares o custo dessa missão, que é rastrear furacões devido ao grande volume de furacões que está havendo no norte da América. Galera, se você está chegando agora, compartilhe essa live para mais pessoas, né? E nós vamos começar aqui. Só estamos esperando agora o sinal lá da NASA. Vai começar, começou. Nós vamos ver se vai ser possível o lançamento hoje, né? O som tá saindo certinho aí? Eu gostaria de ver se o som tá? Temos aqui nosso ajudante aqui, né? Que qualquer coisa vocês perguntam para ele também, ele está aqui para nos ajudar. Na verdade, esse canal é meu e dele. Estamos agora nessa nova empreitada de levar essas informações para você, ok? Não esqueça aí de deixar o like aí na live, compartilhe aí com seus amigos, com mais pessoas, e nós vamos ver se tomara que vai dar certo esse lançamento. Faltam 55 minutos para o lançamento, mas se tudo der certo, pelo jeito vai dar, porque o tempo está colaborando com ok? Vou mostrar para vocês mais informações aqui. Ok, então galera, voltando aqui para a transmissão, falta apenas 48 minutos para essa transmissão. Seja muito bem-vindo aqui ao Astronaut Live, né? Novo canal aqui. Espero que vocês se inscrevam aqui no canal, compartilhem para os seus amigos, para que possamos aumentar aqui o canalzinho Astronaut Live. Seja muito bem-vindo. Espero que curtam aí a transmissão ao vivo sobre esse lançamento do Rocket 3.3, de 2 satélites que irão monitorar furacões na América do Norte, ok? Devido ao aumento do clima, aumento climático, aquecimento global, vem aumentando aí o número de furacões e tempestades fortes, e com isso a NASA vai lançar 6 satélites no total para monitorar os furacões. Nesse primeiro lançamento será 2 satélites, que vão ser lançados para monitorar. Logo haverá o segundo e o terceiro, totalizando 3 lançamentos com 6 satélites no total. O valor total do custo operacional e do valor total vai chegar em cerca de 32 milhões de dólares. Isso é um preço bem moderado devido ao tamanho dos satélites. Os satélites geralmente eram do tamanho de uma geladeira. Para ser lançado, a carga deveria ser maior, ou seja, o foguete que lançaria esses satélites teria que ser maior. Como agora a tecnologia diminuiu para o tamanho de uma caixa de sapato, cerca de 5 kg, sendo 10 kg no total, foguetes menores estão fazendo o lançamento desses satélites. O custo operacional diminuiu muito. E isso vai ser experimental também, galera. Nós vamos estar observando para ver se vai dar certo o total desse lançamento. Falta 45 minutos para o lançamento e fique aí na live. Estamos aqui, vou trazendo informações para vocês, ok? Sejam bem-vindos, tem 4 pessoas aqui na live. Se você não é inscrito aqui, se inscreva. Deixe um comentário aí também, dizendo se está recebendo bem as informações, se o som está saindo perfeito, ok? E vamos continuar aqui, falta 45 minutos, meio-dia agora, meio-dia e 14, a hora do almoço, Daqui a pouco vamos almoçar, não sei se você está almoçando agora, mas deixa aí um comentário aí, o que você está achando, de onde você é, se você está curtindo essa live, ok? Estamos começando esse canal agora, e o meu assistente, o Rômulo. Nós vamos continuar com esse canal, sempre trazendo lançamentos de foguetes, de satélites e tudo mais. Então fique atento aí, deixa aí se inscreva aí no canal, ative as notificações. Sempre vamos estar colocando aqui informações para vocês sobre lançamentos, ok? Então, sobre esse lançamento específico, como eu já dei uma pincelada, as tecnologias hoje em dia proporcionou que fosse feito um satélite bem menor, né, compacto. Geralmente um satélite com esse tipo de tecnologia caberia somente em algo maior, tipo o tamanho de uma geladeira ou maior. Como a tecnologia hoje avançou muito, eles conseguiram fazer um satélite do tamanho de uma caixa de sapato, isso mesmo, cerca de 5,3 kg, o que proporciona um lançamento mais macio, né? Então, galera, vocês que estão chegando aqui, isso aqui é a transmissão oficial, né, da NASA, e nós vamos vou pôr aqui, não vou pôr o som, só vou pôr o som geralmente mais pro final, quando o foguete for realmente lançado. Aí tem os caras aí falando, dizendo que para que serve essa missão e tal. A Space Freight News, né, que está transmitindo essa live, ok? Vou acender a luz aqui para dar uma clareada. Aí, agora acho que ficou melhor. Então, galera, esse projeto desse canal é para lançamentos de foguetes, astronomia e tudo mais, ok? Já se inscreva aqui no canal, compartilha aí para o pessoal que está chegando agora. Esse lançamento específico é para dois satélites, são 3 missões. Primeira missão hoje, 2 satélites, cerca de 10 kg e 600 gramas, os 2 satélites juntos, que vai ser lançado aí na órbita com o objetivo de monitorar furacões, somente furacões ali nos Estados Unidos, América do Norte, ok? Devido ao aquecimento global e a maior incidência de furacões que está ocorrendo naquela região. Então, galera, esse lançamento é experimental, né? E vamos estar aqui trazendo para vocês esta informação ao vivo aqui do canal, ok? Deixa um like aí, hein, galera. Tem 5 pessoas na live. Se inscreva aqui no canal se você não é inscrito. Compartilhe para mais pessoas e vamos que vamos, né? Caso vocês queiram saber alguma informação, deixe um comentário aí o que está achando. Se você quer qual o objetivo desse canal, o que você acha sobre os lançamentos, você crê que o homem vai chegar em Marte? Todos esses lançamentos nós vamos trazer aqui para vocês no canal Astronaut Live, ok? Então, galera, falta 40 minutos para o lançamento e nesse tempo eu vou dar informações para vocês sobre o que é esse lançamento, para que vocês não percam nada sobre esse lançamento da Astra, né? A Astra se preparando para lançar a primeira de 3 missões dedicadas para a NASA neste fim de semana hoje no Cabo Canaveral, na Flórida, Estados Unidos, né? Para implantar 6 satélites de pesquisa de furacões do tamanho de uma caixa de sapato. Isso mesmo, ajudando a abrir um novo paradigma de missões científicas mais arriscadas, porém menos caras. Okay? A empresa de lançamento comercial voltada para a crescente indústria de pequenos satélites ganhou um contrato de 7.950.000 dólares no ano passado, né? Passando para colocar as 6 espaçonaves TROPICS da NASA em órbita, usando os 3 foguetes. Então, essa missão foi contratada pela NASA para uma empresa de tecnologia de construção de foguetes, e o projeto está em 7.950.000 dólares só para lançamento. A primeira das 3 missões TROPICS está programada para decolar durante uma janela de 2 horas, aberta hoje ao meio-dia, já está aberta, né? Hoje. E os meteorologistas prevê tempestade no local do lançamento com mais de 50% de chance de as condições impedirem a decolagem. Tem isso também, galera. Se houver tempestade lá, pode haver que não esteja o lançamento, ok? Sejam bem-vindos. Por enquanto o pessoal está falando, comentando ali. Enquanto isso, vou trazendo mais informações para vocês, ok? Sejam muito bem-vindos aqui ao canal Astronaut Live, ok? Meu nome é Neto, né? E vamos mostrar para vocês esse lançamento. Faltam 37 minutos para o lançamento e logo nós voltamos aqui. Já vai deixando aí um comentário, algo que você queira, tenha dúvida, comente aí para que possamos explicar para você mais sobre esse lançamento. Isso aí com certeza um cientista ou um cara que construiu aí o foguete, ou é o que construiu o satélite, explicando o que está acontecendo, né? Temos também o canal Live Planet, né? Um canal sobre astronomia também e clima, caso você queira se inscrever no canal. É Live Planet, só digitar Live Planet, você vai encontrar o nosso canal Live Planet sobre astronomia, clima e muito mais. Canal muito interessante também, que você pode estar se inscrevendo, ok? Compartilhe com as pessoas com quem você gosta sobre essa live. E vamos aos poucos fazendo com que o canal volte a pegar pessoas específicas nessa área, né? Que goste sobre clima, astronomia e muito mais. Okay? Falta 35 minutos. Então aqui as informações que nós temos aqui também, que a Astra, né, que é o que vai lançar o satélite, entregou o foguete para a costa espacial da Flórida no mês passado, lá de sua fábrica na Califórnia. Então, essa fábrica Astra veio da Califórnia e em seguida completou um teste de disparo com 5 motores de propulsor da Space Launch Complex 46, uma instalação operada comercialmente perto da estação leste da estação da Força Espacial de Cabo Canaveral. Então eles já fizeram o teste e está tudo legal. E os 2 primeiros satélites são montados dentro de um plantador no topo do lançador, né? Tipo no topo do foguete Astra, de 13 metros de altura. É um foguete consideravelmente pequeno, de 13 metros de altura, que a empresa chamada Rocket 3.3 construiu, né, para o lançamento desse foguete. Então, aqui ainda fala que estamos tentando fazer observações aprimoradas dos ciclones tropicais, disse William Blackwell, investigador principal da missão TROPICS do MIT Lincoln Laboratory. Ele diz que estamos realmente tentando caracterizar o ambiente termodinâmico fundamental ao redor da tempestade. Então são coisas como temperatura, quantidade de umidade e a intensidade da precipitação e a estrutura ao redor da tempestade. Esse aí é o objetivo do satélite, galera. Essas são variáveis importantes porque podem estar relacionadas à intensidade da tempestade e até mesmo ao potencial de intensificação futura, disse Blackwell. Na sexta-feira, em entrevista ao Space Flight Now, no canal sobre lançamento, diz: então, estamos tentando fazer essas medições com revistas relativamente altas. Esse realmente é o nosso recurso-chave de constelação trópica que oferece. É a revisitação aprimorada das tempestades. Isso não quer dizer que não tenha outros, mas tem. Mas o principal desse novo sistema é que vai monitorar com mais precisão as tempestades, como a temperatura que está no furacão, a intensidade da chuva, do volume ali de água que tem nesse furacão, nessa tempestade tropical. E com isso eles podem fazer uma previsão melhor do que pode ocorrer em terra com esse furacão, né? Tipo, esvaziar cidades, esvaziar litoral e tudo mais, quando eles já sabem o que está vindo por aí, né? E lá agora em junho já começou a temporada de furacões no América do Norte. E assim, com essa precisão de informações, fica mais fácil fazer um evacuamento de uma grande cidade, por exemplo, tipo Miami, cidades de Houston, Texas também, que pega muito ali, furacão, Nova York e muito mais, cidades com grande densidade populacional, ok? Se inscreva aí no canal, compartilhe, né? Se você não é inscrito, compartilhe, se inscreva aqui no canal. Estamos aqui iniciando esse novo canal, Astronaut Live. Estamos com 56 inscritos. Espero que cresça rapidamente esse canalzinho, que vamos fazer lançamentos e muito mais aqui nesse canal Astronaut Live, né? Faltam 30 minutos, meia hora para o lançamento, ok?
Now inside 22 minutes until launch of Astra's Rocket 3.3
Now inside 22 minutes
until launch
Space
of
Launch
Astra's
Complex 46
Rocket
at Cape Canaveral
3.3
Space Force
vehicle
Station
from
in Florida. Space Launch Complex 46 at Cape Canaveral Space Force Station in Florida. This image taken earlier this year shows Space Launch Complex 46.
This image
taken earlier this year shows
tip of the
Space Launch
easternmost
Complex
extent
46,
of Cape
which is
Canaveral,
located
Florida,
on the easternmost property owned
tip
by
of the
Cape Canaveral
easternmost
Space Force
extent of
Station,
Cape
Canaveral, Florida, on property owned
This
by Cape
launch
Canaveral
facility
Space
is
Force
operated by
Station.
Space
Florida, which is an entity of the state of Florida
This
government.
launch facility is operated by Space
that's
Florida,
set up
which
to
is an entity
attract
of the state
commercial
of Florida
space
government
business to the Sunshine State.
That's set up to attract
Space Launch
commercial
Complex
space
46
business
is
to
a
the
multi-use
Sunshine
pad.
State.
This is the second time Astra will have launched from this facility. It launched the second time Astra will have launched from this package of NASA CubeSats on a mission back in February, but the mission failed to achieve orbit. Package of NASA CubeSats to an issue mission back in February, but the mission failed to achieve orbit. A couple of minutes after liftoff. To an issue encountered during stage separation. This will be the seventh, a couple of minutes after liftoff, or rather fifth orbital launch attempt in history from this pad, or rather fifth to the late 1990s. Launch attempt in history from this pad, Athena dating rockets back to the late 1990s. Pad by Lockheed Martin back in the late 1990s. Rockets launched from this pad, followed by Lockheed Martin back in the late 2017 of a Northrop Grumman Minotaur rocket, carrying a military 2017 of a space surveillance Minotaur rocket, carrying a most recently mission surveillance satellite to orbit, conducted by Astra. And most recently, and in today's mission also by Astra, conducted by Astra, launch attempt from this pad, mission also by Astra, easternmost pad, marks the fifth orbital launch attempt from this pad, which is the easternmost pad. Ships its rockets to the launch site in conventional tractor trailers. Its rockets to the launch site in conventional tractor trailers that fit inside conventional shipping containers. Ground support equipment and the launch vehicle are both sized to fit inside conventional shipping containers. Cape Canaveral, a small team of roughly a half dozen or so technicians and engineers, a small set up the equipment and a half dozen or so technicians and engineers for a static test firing earlier this month. Raised now we're going to play a video for a static test firing earlier this month on pad 46. Now we're going to play last video of the static test on pad 46 last week.
Water on. 7, 6, 10, 5. Water on. 4, 7, 3, 6. Shutdown.
That was a view of the static test firing of Astra's Rocket 3.3 vehicle last week. Static test firing at pad 46 of Astra's Rocket 3.3 vehicle last week. Liftoff now less than 19 minutes away. Today's launch attempt. At the opening of a 2-hour window. Liftoff now less than 19 minutes away for 12 p.m. At the opening of Eastern Daylight Time. The opening of the window is scheduled again for 12 p.m. UTC Eastern Daylight Time. The weather forecast as issued this morning was iffy. With weather, just a 40% chance of favorable weather at the opening of the window. However, just a 40% chance of favorable weather at the opening of the window. However, all weather rules are green and go for launch at this time. At Cape Canaveral show all weather rules are green and go for launch at this time. Weather forecasters will be monitoring the conditions throughout the rest of the countdown, though, to see if there are any thunderstorms conditions throughout the rest of the countdown, vicinity that have any threat of lightning, thunderstorms, cloud cover that pop up in the vicinity that have any threat of lightning to the rocket, cloud cover that forms over the launch pad that may pose a threat to the rocket as it climbs through the atmosphere.
The launch countdown for today's launch of the TROPICS satellites is now holding. The launch countdown for today's launch of the TROPICS satellites is now holding. We're not sure yet of the reason for this hold, however. The countdown is stopped at 15 minutes for this hold. However, the launch window today extends until 2 p.m. Eastern Daylight Time. However, the launch window today extends until 2 p.m. Eastern Daylight Time. However, expectation going into the launch countdown this morning this afternoon was that the best weather conditions going into the launch countdown this morning available at the opening of the window at noon Eastern. Most likely available at the opening of the window at noon Eastern. The weather conditions still are all green and go for launch at this time. The weather conditions still are all green and go for launch at this time. Astra's countdown continues to hold at T-minus 15 minutes. Astra's countdown continues to hold at T-minus 15 minutes.
Astra has not provided an update on
any word on what
reason
issue
for the
may
hold.
be Astra has not provided an
reviewed
update
by the
on
launch team.
What
Astra's
issue
launch
may
team
be
is
stationed
being
at the
reviewed by the
company's
launch
factory
team.
and headquarters
Astra's
out
launch
in
team
Alameda,
is
California.
stationed
At the
in the
company's
Bay Area
factory and headquarters out in
the
Alameda,
launch team up there
California
is
actually controlling
the Bay Area
the countdown and monitoring the countdown.
launch team up
while
there is actually controlling
much smaller team of
the
technicians
countdown
and monitoring
is on
the
site
countdown
here at
while
Cape Canaveral
for any
much smaller
hands-on
team
work
of
on the vehicle that may
technicians
be
is
required
on
for
site here at
troubleshooting
Cape Canaveral
for any hands-on work on the vehicle that may be required for troubleshooting any issue today. Once the rocket lifts off, it will be heading downrange toward the east-northeast. Once the rocket lifts off, it will be heading downrange. 5 Delphin engines will be ignited on the launch pad. Those will throttle up to produce 5 Delphin engines will be ignited on the launch pad. Those will throttle up to produce about 6,500 pounds of thrust each, combining for about 32,500 pounds to power the 43-foot tall Astra rocket 3.3 vehicle power off the 43-foot tall. At 6 seconds after liftoff, the rocket will begin a pitch-over maneuver to start lining itself. At 6 seconds after liftoff, the rocket will begin a pitch-over maneuver to start lining itself with its planned trajectory. In less than a minute, the rocket will be supersonic, and in about T+1 minute and 10 seconds, the rocket will be supersonic, and in about T+1 minute and 10 seconds, it will pass aerodynamic pressure on the vehicle as it accelerates the period of maximum aerodynamic pressure. Those 5 Delphin engines burning kerosene and liquid oxygen will fire for about 3 minutes. Those 5 Delphin engines burning kerosene and liquid oxygen will fire for about 3 minutes. 5 seconds later by the jettison of the payload fairing, that'll be followed 5 seconds later by the jettison of the payload fairing, that's the nose cone, that will reveal the second stage of the vehicle Astra rockets, the TROPICS satellites, that will reveal the second stage of the vehicle and at T+3 minutes and 10 seconds, the upper stage will be separated from the first stage booster. At T+3 minutes and 10 seconds, the upper stage will not be separated from the first stage booster, which will fall back into the Atlantic. And then at T+3 minutes and 15 seconds, launch vehicle. Second stage, and then at T+3 minutes and 15 seconds, a small thruster producing about 700 pounds thrust. Ether engine, 740 pounds small thruster producing about 700 pounds thrust for a burn lasting more than 5 minutes. Also, burn will actually accelerate for a burn lasting more than 5 minutes. And this burn will velocity accelerate of around 17,000 miles per hour. Satellites to orbital velocity, and those engines around 17,000 miles per hour. T+8.5 minutes. And those engines, and 10 seconds later, stage will cut off. Command will be issued 8.5 minutes deploy or eject. 10 seconds later, satellites from the command will be issued to on top of the rocket deploy or eject. And those satellites from their container from the rocket on top of the rocket. And their automated checkout sequence will be ejected from power on. And begin their automated checkout testing and activations. Automatically power on. Ground teams hope to receive signals from the TROPICS satellites. And then sometime ground teams hope to receive signals from the TROPICS satellites to confirm their health. Sometime in their first day or two after their aliveness after the launch on Astra's Rocket 3.3 vehicle. Their aliveness after the launch on Astra's Rocket 3.3 vehicle. The countdown continues to hold at T-minus 15 minutes. The countdown continues to hold at T-minus 15 minutes. You're continuing to look at a live view of Space Launch Complex 46. You're continuing to look at a live view of Space Launch Complex 46. Crowds are now gathering at Jetty Park at Cape Canaveral Space Force. This location is about 5 miles away now gathering at Jetty Park. And this rocket is about 5 miles away from the pad. Weighs about as much as this rocket is loaded 43 feet tall business jet. Weighs about as much as a fully loaded Cessna business jet. This is actually the smallest currently flying, currently operational orbital class. This is actually the smallest currently flying, currently operational thrust orbital class rocket that's ever flown successfully. And the lowest thrust orbital class rocket that's ever flown successfully to orbit. Unfortunately, NASA and the U.S. Space Force are not escorting. Unfortunately, NASA and the U.S. Space Force are not escorting to give us a better view of the rocket viewing site for this particular mission. We hope that changes view of the rocket going forward for the next 2 TROPICS missions. We hope that changes again. This going launch is for the next 2 TROPICS missions. 6 TROPICS hurricane research satellites. Launch is deploying the first 2 of 6 TROPICS parameters like the temperature, these satellites moisture content. Throughout parameters like the temperature in the atmosphere and moisture content regions inside and around columns in the atmosphere. And this information will help inside and around scientists learn more about how and why tropical cyclones intensify. Scientists learn more about how and why tropical cyclones intensify. These two satellites on board this mission are each about the size of a loaf of bread. These two satellites on board this mission are each about the size of a loaf of bread or a shoebox. They weigh about 11 very small to 12 pounds, or about 5.3 kilograms. These hurricane very small satellites collecting. NASA has 4 more TROPICS CubeSats fully assembled already. NASA has ready 4 more TROPICS CubeSats launches assembled already and ready for shipment in mid-July. The goal is to have all 6 of these satellites in orbit, as well as in mid-July. The goal is to have all 6 of these satellites in orbit of the Atlantic hurricane season, and collecting data in August in time for the peak of the Atlantic hurricane season toward the end of August and in September. This mission will be targeting a low inclination orbit of an inclination of 29.75 degrees low inclination orbit to the equator. An inclination of 29.75 degrees. The orbit to the parameters for this mission are calculated, and parameters for this mission are satellites to regularly pass over the tropical regions of Earth due to the requirement for these satellites. Again, the goal of the mission is to focus on the development of tropical cyclones. So in this type of goal of the mission is to focus on the development of tropical cyclones. Pass over. So in this type of orbit, any individual storm tropic satellites with a pass rate of about once per hour, less than once per hour, with a rate of about once per hour, greater than less than once per hour, about once every 50 minutes with all 6 satellites in orbit. Greater than once per hour. That's the benefit of about once every 50 minutes with all 6 satellites in orbit. And that's the benefit of these small satellite pass over a storm. Is that a couple of times a day. You have one satellite, you only pass over a storm focused on a couple of times a day regions with 6 satellites over these storms every focused on the tropical regions. And to reach this orbit, Astra's rocket 3.3 vehicle will be heading. And to reach this orbit, downrange toward rocket 3.3 vehicle will be heading east-northeast from Cape Canaveral. Downrange toward the east-northeast from Cape Canaveral. Along the map shows the expected ground track. This red downrange from track along the Space Launch Complex 46, which again is downrange from Cape Launch Space Launch Complex 46, which again is the easternmost launch pad here on Florida Space Coast near the eastern tip of Cape Canaveral. The countdown is resumed now. The Astra countdown now T-minus 11 minutes and 20 seconds and counting. The Astra countdown now T-minus 11 minutes and 20 seconds and counting earlier. After clearing liftoff, whatever issue that was 11 minutes and 10 seconds earlier. So liftoff now 11 minutes and 10 seconds away. Copy that. I guess that's on the stream deck, right? Copy that. I guess that's on the stream deck, right? Now 9 minutes and 20 seconds until launch of Astra's rocket 3.3 Now 9 minutes and 20 seconds is now scheduled for launch of Astra's rocket Eastern Daylight Time vehicle, or 16 liftoff is now scheduled for 12:12. The issue that caused Daylight Time countdown hold earlier was a boat in the downrange. The issue that caused the countdown hold earlier was clearing the area downrange, and the range is currently clear. That boat is now clearing the area p.m. Eastern Daylight Time. The range is currently clear for launch at 12:12 p.m. Eastern Daylight Time.
Now inside of 7 minutes until launch, 6 minutes and 31 seconds. Now inside of 7 minutes until launch, 6 minutes launch and 31 seconds to be exact. For the final poll of Astra's launch team, NASA TROPICS CubeSats on top of the Astra Rocket 3.3 vehicle. The NASA TROPICS CubeSats on top of the Astra Rocket 3.3 vehicle 6 minutes and 15 seconds. Now 6 minutes and 15 seconds. T-minus 2 minutes and 30 seconds. T-minus 2 minutes and 30 seconds. A poll showed that the eastern range here at Cape Canaveral is green for launch. A poll showed that the eastern range here at Cape Canaveral is green for launch. Now less than 2 minutes until launch. Now less than 2 minutes until launch. 1 minute, 40 seconds. 1 minute, 40 seconds. Hold, hold, hold. The countdown is holding. Hold, hold, hold. The countdown is holding. The countdown is holding just as we saw a countdown is holding just as we saw a pass through the channel here at Jetty Park. Recovery boat pass through the channel here at Jetty Park. The countdown is holding just outside of 1 minute until launch. The countdown is holding just outside of 1 minute until launch.
Again, if you're just joining us, the Astra countdown is holding at about T-minus 1 minute and 10 seconds. Astra countdown is holding in the final moments of the countdown. 10 seconds. We haven't heard a reason for the hold yet. In the final moments of the countdown was targeting a launch at 12:12 p.m. Eastern Time. The countdown was targeting a launch of UTC. 12:12 p.m. Eastern Time or 2 p.m. 12 UTC. The window today extends until 2 p.m. Eastern. Astra's countdown continues to hold. The latest update from Astra's countdown continues to hold is allowing the team to complete conditioning of liquid oxygen on the vehicle. This is allowing the team to complete conditioning of liquid oxygen on the vehicle.
Rocket's liquid oxygen is in combination with kerosene fuel consumed by the liquid oxygen engines stored at cryogenic temperatures fuel and the liquid oxygen is a couple hundred stored at cryogenic temperatures. So right now the team is making sure that 200 degrees below zero Fahrenheit oxygen is at the correct temperature. Right now the team is making sure conditioned for liquid oxygen is at the correct temperature, expected performance during today's flight. For the rocket to achieve the expected performance during today's flight. Again, all weather parameters at this moment remain observed green. Again, all weather parameters at this moment remain observed green or go for launch. The Astra countdown remains in a hold at this time. Again, this mission will be Astra countdown remains in a hold at this time. For again, this mission will be these satellites will be two tropic satellites at an altitude of 357 miles. Satellites will be 550 kilometers at an altitude of 357 miles. Cruise ship passes in our field of view. At Jetty Park, now as a cruise ship passes in our field of view to pass momentarily. At Jetty Park, here's an animation of the tropics satellites, what they'll be doing in orbit. Here's an animation of the tropics about 11 pounds, what they'll be doing in orbit. Or a loaf of bread. Each satellite weighs about 11 pounds, and the microwave radiometer or a loaf of bread the size of a coffee cup. The instrument on the satellite is a microwave radiometer spinning at 30 rounds per minute. Coffee cup. And that radiometer is actually spinning at 30 rounds per minute. 6 satellites will be making repeated passes once every 2 seconds, cyclones, and collecting data on their intensity, repeated passes things like the water vapor content inside the storms, as well as the temperature, things like different altitudes, water vapor content inside the storms, and around the temperature, cyclones, and different altitudes. This animation from NASA shows within and around these tropical cyclones. This animation from NASA shows what these satellites look like as they are fully deployed with their solar panels out and their spinning radiometer instruments in action in low Earth orbit. The countdown continues to hold now at T-minus about a minute before launch. Countdown continues to hold now an updated launch time from Astra. About a minute before we get that launch time, we're waiting on an updated launch time from Astra. Countdown to be once we get that launch time hold point confirmed, we expect the countdown to be recycled likely around 15 minutes. Hold point at T-minus 15 minutes is our expectation. Likely around 15 minutes will be picked up from that point is our expectation. Down toward the new target launch time will be picked up from that window today extends until 2 p.m. Eastern Daylight Time. The launch window today extends until 2 p.m. There are some rain showers starting to build 1800 UTC over Central Florida. There are some rain showers starting to build moving generally to the northeast over Central Florida. Currently, weather conditions showers are moving generally to the northeast. Cape Canaveral are still go. Currently, weather conditions here at this time for Cape Canaveral are still go. Remains to be seen if those conditions green at this time for remain green and go, but it remains to be seen if those conditions sets their new target remain green and go liftoff time for launch when Astra sets back live now with that cruise ship has liftoff time passed through our field of view. We're back live now with that cruise ship has we're continuing to look at a live field of view heading toward Astra's rocket 3.3 on Space Launch Complex 46 of Astra's rocket 3.3 on Space Launch Complex 46 at Cape Canaveral, looking toward the northeast, about 5 miles away from the pad. At Cape Canaveral, looking toward the northeast, Astra's rocket 3.3 stands 43 feet tall, about 13 meters in height. Astra's rocket 3.3 stands 52 inches 43 feet tall, about 13 meters in height. The smallest 52 inches in diameter, currently flying, currently operational. It's the smallest orbital class rocket currently flying, currently operational. This rocket is just about this rocket is just about 20% of the height of SpaceX's Falcon 9 rocket. 20% of the height of a very small launch vehicle. SpaceX's Falcon 9 tailored to hauling these small, very small launch nanosatellite type payloads. Tailored to hauling these small CubeSat nanosatellite type payloads. Astra's 7th orbital launch attempt dating back to 2020. This will be Astra's 7th orbital launch attempt dating back to 2020. Previous attempts made by Astra to reach orbit. 2 have succeeded. And of the 6 so this rocket previous attempts made by Astra to reach orbit, 2 have succeeded. So this rocket is still relatively unproven. This mission is early in its life cycle. Contracted by NASA, and this mission is contracted with Astra. Contracted by NASA. Dedicated launches NASA has on the company's rocket with Astra vehicle. For 3 dedicated launches. The first of the company's to carry those Tropic 3 vehicles. Satellites into orbit to begin missions monitoring tropical cyclones. Satellites into orbit to begin missions monitoring tropical cyclones. We'll continue to stand by for word from Astra on the status of the countdown. Continue to stand by for word from Astra. Astra might make another run at launch. Status of the countdown today, and again, the launch window Astra might make another run at Eastern Daylight Time today. Again, the launch window extends until 2 p.m. Eastern Daylight Time. The countdown continues to hold now. We're still waiting on an updated launch time from Astra. The countdown continues to hold. However, now we're still waiting on an updated launch time from Astra. Deteriorate here in Central Florida. The weather conditions are starting to pop up inland. Deteriorate here in Central Florida. Generally to the northeast. Thunderstorms starting to pop up inland. These storms are heading generally to the northeast, as you can see. Astra says the eastern range, the weather team at Cape Canaveral Space Force Station. Astra says the eastern range, the weather team at Cape Canaveral Space Force Station for about another 15 or 20 minutes. It's expected to remain favorable for launch for about another 15 or 20 minutes. Or red for launch. After that, the rest of the window is expected to so Astra is kind of racing against the clock right now to resolve this liquid oxygen conditioning issue. Astra is kind of racing against the clock right now to resolve this liquid oxygen conditioning issue before the weather starts to deteriorate and storms start to move in near the launch site. Starts to deteriorate and storms start to move in near the launch site. The launch window does extend until 2 p.m. Eastern Daylight Time, or the launch window UTC. Does extend until 2 p.m. Eastern Daylight Time. Weather conditions are not expected to be favorable throughout that time period. Throughout the window, conditions are not expected to be favorable throughout that time. Another 15 or 20 minutes available. So Astra expects to get this another 15 or 20 minutes available for good weather to get this launch off the ground today. Astra's countdown remains in a hold. This hold was called at about a minute before Astra's countdown remains in a hold. The launch team for Astra was called at about a minute before stationed out in California, and the launch team for Astra, which is stationed out in California, of this countdown, is currently
to do remote monitoring,
working through an issue involving liquid oxygen conditioning.
Is currently
make sure that the
working
oxidizer
through an issue involving liquid oxygen
conditioning
is at the
to make
proper
sure that the
conditions,
oxidizer
proper temperature
on board the
for
rocket
launch
is
today.
at the proper conditions, proper temperature.
Weather conditions
for
remain
launch
green
today.
at this moment,
But there are storms
weather
building
conditions
inland
remain
moving generally in the
green at this
direction of
moment.
Cape Canaveral Space
But
Force
there are
Station
storms building inland
that
moving
could generally in the
pose a
direction
problem
of Cape
later in the
Canaveral
window.
Space Force Station that could
So Astra's
pose
hoping
a problem
to
later
resolve
in the
this
window
issue
and resume the countdown. So
Astra's
Astra's
hoping
hoping
to
to resolve
these
this
weather
issue and
conditions
resume the
turn,
countdown before
and
these
go
weather
red.
conditions turn. The launch window extends until 2 p.m. Eastern Time
red.
or 1800 UTC. The launch window extends until 2 p.m. Eastern Time or 1800
You're
UTC.
looking
Live at Space Launch Complex 46 at Cape Canaveral Space Force Station.
live at Space Launch
where
Complex
Astra's Rocket 3.3
at Cape
vehicle
Canaveral Space Force
is
Station
currently
where Astra's
standing
Rocket
vertical
3.3
stands 43
vehicle
feet tall is currently standing
awaiting
vertical
a
stands
launch
43
opportunity
feet tall
today.
awaiting a launch opportunity today. Again, NASA and the U.S. Space Force, which typically provide media access
NASA
to
and the
viewing
U.S. Space
site,
Force,
which typically
relatively close to
provide
the
media
launch
access
pads,
to viewing
within the
site
safe
zone around the launch
relatively
pad.
close to the launch pads
Within the
those
safe
entities are not
zone around
providing
the launch
any
pad.
media access to a
Those
viewing
entities
site
are
with a
not
clear
providing
view of the
any
launch
media
pad
access
today.
to a
So we're
viewing site with a
positioned
clear view
about
of the
5
launch pad
miles
today.
away from the pad.
So
at Cape
we're
Canaveral on the
positioned
beach,
about
you're
5
looking
miles
generally
away from the pad,
northeast
at Cape Canaveral
towards
on the
Space
beach.
Launch Complex
You're looking
46.
Generally, Astra's rocket
northeast is the
towards
small
Space Launch
vertical,
Complex 46.
feature
Astra's
visible on
rocket
the horizon
is the
in
small
between the
vertical
two taller
lightning
feature
protection
visible on the
towers
horizon
on each
in
side of the
between
launch
the
pad.
two taller
So the
lightning
shortest
protection towers
the shortest
on
structure
each
you're
side of the
actually
launch
seeing
pad.
out toward the launch pad.
So the shortest
is indeed the rocket.
The shortest
is dwarfed
structure
by
you're actually
those
seeing
lightning
out toward the
protection
launch
towers
pad
as well as the
is
mobile
indeed
service
the rocket.
gantry.
It's
At
dwarfed
pad
by
46.
those lightning protection towers as well as the mobile service gantry at pad 46.
We do expect the rocket to be clearly visible, though, once it lifts off from pad 46. We do expect the rocket to be clearly visible, though, once it lifts off from pad 46. You're now looking at a closer view of Astra's Rocket 3.3 vehicle. You're now looking at a closer view of Astra's Rocket 3.3 vehicle. Astra at Pad 46. This view provided by a live stream. You can see the 43-foot tall vehicle standing vertical, venting oxygen vapors. You can see the 43-foot tall vehicle standing vertical, venting oxygen vapors. And you can see part of the Atlantic Ocean on the horizon diameter in this view. And you can see part of the Atlantic Ocean on the horizon there Rocket 3.3 at Space Launch Complex 46. Of Astra's countdown remains in a hold at this time at Space Launch Complex 46. The countdown remains in a conditioning of liquid oxygen. There's been no further explanation of that. An issue involving the conditioning of liquid oxygen. In this view from Astra and NASA spaceflight shows the countdown clock in this view from Astra and NASA spaceflight shows the clock holding at T-minus provided 31 seconds. Ground teams here at the Kennedy Space Center provided by is actually T-minus 1 minute and 10 seconds, so we don't know the reason for the discrepancy. It is actually T-minus 1 minute and 10 seconds, so we don't know the reason for the discrepancy in the hold time. Launches to proceed today, the countdown clock to recycle back to an earlier point proceed today. A few minutes countdown clock to recycle back the countdown to an earlier point to recycle and restart a terminal countdown to target a new launch time. To recycle and restart a terminal countdown to cycle back perhaps as far back as T-minus 15 minutes. So we do expect to see the clocks cycle back, attempt a second launch as far back as T-minus 15 minutes. Run through the countdown today. Attempt a second launch assumes a second run through the countdown. Liquid oxygen conditioning issue is resolved. Also assumes that the liquid oxygen conditioning issue is resolved for launch, and also assumes as they currently that the weather conditions here remain at Cape Canaveral. However, the forecast is for the conditions to deteriorate with storms moving in. However, the forecast is for the conditions to deteriorate with storms moving in throughout the afternoon. As the clock approaches 1 p.m. Eastern Time here on Florida Space Coast, the launch window for today is now 1 p.m. Eastern Time here on Florida Space Coast. The launch window for today is now halfway to 2 p.m. Eastern, or 1600 window extended from 12 p.m. Eastern. The Astra countdown remains in this hole that was called about a minute before the scheduled launch of remains in this hole that was called about a minute before the scheduled launch 12 p.m. Eastern Time. Astra rocket. So the hold has now been in place for nearly 50 minutes. So the hold has now been what they're referring to as nearly liquid oxygen conditioning issue. As Astra works through what they're referring to as a liquid oxygen conditioning issue of the rocket. Liquid oxygen is the oxidizer used on both stages of the rocket. Engines at the base of the first stage, as well as the single E5 engine on the upper stage engines at the base of the first stage, as well as the single ether engine on the upper stage. Both stages vehicle consume that liquid oxygen in combination with both stages kerosene fuel. Consume that liquid oxygen as it's called in combination with which is a highly refined RP-1 as it's called, Rocket Propellant 1. This mission is carrying 2 satellites into orbit for NASA's TROPICS constellation. This mission is carrying 2 satellites into orbit for NASA's TROPICS constellation. 6 satellites flying in formation in 3 orbital planes of 6 satellites study hurricanes. Flying in formation in 3 animation from NASA shows what the satellites study hurricanes when they're in orbit. This animation from NASA shows what the satellites will look like when they're in orbit, with a spinning radiometer instrument on the end that's the size of bread, the size of a coffee cup. Spinning radiometer instrument on the end, radiometers will be scanning tropical cyclones to measure their microwave radiometers will be scanning tropical cyclones vertical column of the atmosphere inside and around hurricanes and tropical storms. Vertical column of the atmosphere inside and around hurricanes and tropical 3 different orbital planes, and 6 of these satellites will the same regions of the tropics 3 different orbital planes 15 minutes to fly over the same regions much more rapid about once every 50 minutes view of what's going on, and that'll provide a much more rapid and regularly updated view of what's going on inside hurricanes. You're looking now again live at Pad 46 at Cape Canaveral Space Force Station from our vantage point. Live at Pad 46 at Cape Canaveral Space Force Station. The Astra vehicle vantage point again is about 5 miles small by rocket standards. The Astra vehicle stands again 43 feet, relatively small by rocket standards, and it stands visible there on the horizon in between the 2 larger and its antenna visible there on the horizon lightning protection masts. At Pad 46, those tower-like lightning protection rockets from lightning strikes while it's on the pad. Masts to the left of the rocket is the large from lightning strikes mobile it's on the service gantry that's used to the left of the rocket is the large to stack mobile service gantry that's used for some missions. Astra does not use that facility. Different components of the rocket brings in its launch equipment on its Astra trailers. That facility sets them up. It brings independent equipment on its own trailers and sets them up. Also see some photographers and spectators gathered on also see some photographers and spectators of today's launch gathered on Jetty. Weather parameters continue to be favorable. To get a view of today's radar shows thunderstorms continue to be favorable, more numerous. But the radar shows across thunderstorms continuing to build. The radar become more numerous. Shows them moving in the general direction of Cape Canaveral, and the radar shows them moving in the general direction of Cape Canaveral. as we await word from Astra on the progress in resolving this liquid oxygen conditioning issue, issue that they're we're also watching the weather radar for the Florida Space Coast, which is showing we're also watching activity than radar showed a couple of hours Space Coast, which is more showers and thunderstorms, a lot more activity than it showed a couple of hours ago. Florida, moving in more showers and thunderstorms developing. Inland across Central Florida, shower, moving in a general direction toward the northeast. The spaceport one rain shower, but it's not passing directly over the launch spaceport right now. View from it's not passing directly our location over here at the Kennedy Space Center launch pad. You can see in our view from rain clouds our location here at the Kennedy Space Center. On the right side, you can see a rain shaft. Rain clouds moving from that rain shower passing on the right side. You can see a rain shaft Space Force Station this time from that rain shower passing over. Right now, the weather conditions remain green at this moment, but the right now the weather conditions remain clear for launch at this moment. Were to occur now, the sky over the launch pad is clear for launch. The situation is dynamic. The weather situation is evolving. As you can see, the launch window extends until 2 dynamic. The weather situation is evolving. There's no guarantee that the weather will remain go 2 p.m. Eastern time. Remaining 43 minutes. There's no guarantee that the weather will remain. In the meantime, the other thing being tracked 43 minutes is of the window status. In the meantime, the other thing being tracked as they work to resolve status of the countdown from Astra conditioning issue as they liquid oxygen to resolve on board the rocket conditioning issue with liquid oxygen on board the rocket out at pad 46. We're now showing a live view of Astra's Rocket 3.3 vehicle at showing Pad 46, a live view of Astra's Rocket 3 and NASA space flight, which is streaming the launch for Astra and NASA space flight, which is streaming the launch vehicle vertical and oxygen vapors. This shows streaming away from the vehicle vertical. And oxygen vapors are visible streaming away from the vehicle. More or less fully loaded with propellants at this time. The rocket is more or less fully loaded is about the same as the small business jet. The rocket fully loaded weighs 43 feet tall and 52 inches business jet. The vehicle is 43 feet tall and 52 inches at the bottom of the rocket will be generating, and the 32,500 pounds of thrust at the bottom of the rocket will be generating 32,500 pounds of thrust at liftoff. And once again, here's our view from 5 miles distant, showing the. And once again, here's Astra rocket view from 5 miles distant, showing the Astra rocket. As I mentioned, the rocket is 43 feet tall. That's about 1/5. As I mentioned, the rocket is 43 feet tall. That's about a SpaceX Falcon 9 rocket. The height, approximately, of entire Astra Falcon 9 is roughly the height of. In fact, the entire Astra rocket shroud is roughly the height of the payload fairing, the nose shroud, makes the Astra Rocket 3.3 vehicle the smallest
This makes the Astra orbital-class rocket currently in operation anywhere in the world. Orbital-class rocket currently in operation anywhere in the world. As we continue to wait for an update from Astra on the progress of their troubleshooting, continuing to look at a live view of Space Launch Complex 46 on the left, continuing to look at a live close-up view from a Space Launch Complex 46 on the left, provided by Astra, and a close-up view from a camera near the pad, provided by Astra and their camera position streaming partner 5 miles away. On the right, Jetty Park, from our camera position, about 5 miles away site for us today. Jetty Park, because NASA and U.S. Space Force viewing site for us today. Access to NASA and U.S. Space Force close-up are not viewing site for this mission. Access to photographers typically do for most launches from here on viewing site for this mission. As they typically do for most launches, position a little more distant than we normally do. So we've had to go to a you're seeing on the right-hand side of the screen. Than we normally do. And that's the view you're seeing on the right-hand side. If you want to support our coverage, you can go to spaceflightnow.com and click the members tab at the top of the homepage. Spaceflightnow.com and click the members tab near the top of the homepage. Helps us continue and improve our coverage of launches that you can provide here in Florida and continue and improve our coverage of launches here in Florida and other sites around the world. Spaceflightnow.com and visit the Spaceflight Now store. You can also go to shop.spaceflightnow.com and visit the Spaceflight Now store memorabilia to collect associated with historic and current space missions. Memorabilia associated with historic and current space missions. Astra is setting up for another possible launch attempt today. Astra is setting up for another possible launch attempt today. The latest report, countdown clock will be recycled. Launch Control said the team out at the control center. Countdown clock will be recycled. California will be pulled out at the control center to proceed into Alameda, California once again this afternoon for a go or no go. There's also a check scheduled with the Eastern Range, which is run by the U.S. Space Force here at Cape Canaveral to make sure that the launch has various clear of all aircraft and boats, to make sure that, and also to check on the status of weather clear of all aircraft and weather criteria, and also to check on the status of weather this afternoon continues to be dynamic with as the rain showers popping up inland and heading in the general vicinity of Cape Canaveral. Rain showers popping up inland looked like it was going to be clipping the spaceport, passing over one of those showers a few minutes ago. Looked like it was going to be clipping the spaceport, passing over the spaceport a few minutes ago, but fizzled out just before reaching the coast. So it's going to be a race against the clock for the launch window closure at 2 p.m. as well as going to be a race against the clock for the launch window closure at 2 p.m. as well as the weather conditions another run through that terminal count. See if Astra can recycle the countdown and make another run through that terminal count and launch before 2 p.m. Eastern Time. And the countdown clock has resumed now. We haven't heard officially that the countdown clock has resumed now. We haven't heard officially that the launch milestone in the coming minutes. The countdown is ticking, targeting a launch milestone in 1:43 p.m. Eastern Daylight Time, or targeting launch time of 1:43 p.m. Eastern Daylight Time, or 17:43 UTC. As Astra counts down toward another launch attempt today, that liftoff as Astra counts down toward another launch attempt today, that liftoff is now targeted for 1:43 This mission will be carrying 2 nanosatellites into orbit. These are 11 to 12 pounds. This mission will be carrying 5 nanosatellites into orbit. These are nanosatellites for NASA's TROPICS mission, which is dedicated kilogram to nanosatellites for NASA's TROPICS conditions within hurricanes. To these two satellites will be deployed into an orbit conditions about 357 miles. These two satellites will be deployed into an orbit of Earth about 357 miles
shows the major events expected during the flight. Above 5 Delphin engines. This shows the major events expected during the flight. 5 Delphin engines at the bottom of the pad. Astra rocket 3,500 pounds thrust power the kerosene and liquid oxygen with 32,500 pounds thrust pitched over and kerosene and liquid oxygen on its trajectory toward the east. The rocket will be pitched over and it'll pass the speed of sound in less than a minute. Beginning at T plus 70 seconds, it will pass the speed of sound in less than a minute. And then at T plus 70 seconds, it will pass the pressure on the vehicle during the climb through the atmosphere. Those 5 first stage engines will continue firing until the climb through the atmosphere. 3 minutes. 5 first stage engines, those engines will firing until T plus. And the nose fairing on top of the vehicle will be jettisoned 5 seconds later to reveal the upper stage on top of the vehicle will be jettisoned 5 seconds later to reveal the upper stage later at T plus 3 minutes 10 seconds by stage separation. 5 seconds later at T plus 3 minutes 10 seconds by stage separation. The first stage will fall back into the Atlantic Ocean. The second stage engine will then ignite its single engine, producing 740,000 pounds of thrust. Then ignite its single engine, producing 740,000 pounds of thrust. That burn lasts about 5 minutes, a little more than 5 minutes, 15 seconds. Accelerate that burn lasts about 5 orbital velocity, 5 minutes to accelerate nearly 8 kilometers per second, orbital velocity 5 miles per second. Nearly 8 kilometers per second. That'll set the stage for deployment of the 2 TROPICS satellites at T plus 8 minutes and 40 seconds. That'll set the stage for deployment of the 2 TROPICS satellites. This map shows the approximate ground track of the vehicle. It'll be heading just north. Map shows the approximate ground track of the vehicle. It'll be heading just north Space Launch Complex 46, Cape Canaveral Space Force Station, launching from Space Launch Complex 46, which is the easternmost pad at Cape Canaveral, Florida. Now less than 8 minutes until liftoff. You're looking now again live at Space Launch Complex 46. Now less than 8 minutes until liftoff. You're looking now again live at Space Launch Complex 46. Barely visible there on the horizon. The Astra Rocket 3.3 vehicle is become much more visible there on the horizon, but starts heading downrange. Become much more visible once it clears the tower in height, starts heading downrange. Orbital class rocket. This rocket again is 43 feet anywhere in the world. It's the smallest orbital class rocket currently flying anywhere in the world. Now, inside of 3 minutes until launch, the final polls have been completed. Now, inside of 3 minutes until launch, the final polls confirming that all stations, all parameters are green for launch. Weather conditions confirming that all stations, all parameters are green for launch. 3.3 from Cape Canaveral Space Force Station for launch of Astra's rocket 3.3 from Cape Canaveral Space Force Station. Now 1 minute and 50 seconds. Now 1 minute and 50 seconds. T-minus 1 minute 45 seconds. In the next few moments, the propellant tanks on Astra's 1 minute 45 seconds pressurized for flight. Few moments, the propellant tanks on Astra's vehicle will be pressurized for flight. One minute to go. 1 minute until launch of Astra's Rocket 3.3 vehicle. 1 minute to go. NASA's 1 minute until launch of Astra's Rocket 3.3 vehicle. Beginning a mission for NASA's hurricane research. First 2 Tropics CubeSats. Beginning a mission for hurricane research. T-minus 20 seconds. T-minus 20 seconds. T-minus 5 seconds, standing by for ignition and liftoff. T-minus 5 seconds, standing by for ignition and liftoff. And there's liftoff of Astra's Rocket 3.3. Carrying 2 of NASA's Tropics Rocket 3.3 hurricane research satellites into orbit. Carrying 2 of NASA's Tropics hurricane research satellites into orbit from Cape Canaveral, Florida. Now T plus 1 minute, everything looking good so far in this flight of Astra's Rocket 3.3. Now T plus 1 minute, everything looking good so far in this flight of Astra's Rocket 3.3.
Now approaching main engine cutoff. Good burn so far reported by the first stage. Now approaching main engine cutoff. Good burn so far reported by the first stage. And there's main engine cutoff. Here's an onboard view showing, and there's main engine cutoff. We just had fairing, payload fairing, jettison. Onboard view showing, looks like we just had fairing, payload fairing of the upper stage. And separation of the upper stage. This onboard view shows the upper stage engine. This onboard view shows the upper stage engine. Astra's rocket now passing an altitude of 300 kilometers. Astra's rocket now passing an altitude of 300 kilometers. TROPICS hurricane research nanosatellites into orbit to place these two TROPICS. The first stage burn research nanosatellites into orbit. The 5 engines fired for about. The first stage burn looked like it was a good 3 minutes or so, and then 5 engines separated about. The payload fairing jettisoned 3 minutes or so, and then the booster separated. Payload fairing jettisoned, and then the upper stage begin this orbital insertion. A few moments later, separated burn and ignited. Expected to last until T plus 8 minutes orbital and 30 seconds. Burn. This burn is expected to last until T plus 8 minutes and 30 seconds. This view on the left-hand screen shows the expected ground track for today's mission. Heading on the left-hand screen shows the expected ground track for today's mission. Space Force Station on the right, just north the view of the upper stage engine. Away from Cape Canaveral Space Force Station on the right, and onboard view of the upper stage engine with these 2 tropic hurricane research satellites on board. As it powers into orbit with these 2 tropic hurricane research satellites on board. Now approaching 7 minutes into the mission, good telemetry from the upper stage. Now approaching 7 minutes into the mission from the good telemetry from the upper stage, showing the ether engine in operation from the ether engine upper stage, showing about 740 pounds thrust. The ether engine producing about 740 pounds so far in this upper stage burn, according to Astra. Everything going well so far in this upper stage burn, according to Astra.
And now we see the velocity meter starting to decrease. And now we see the velocity meter starting to decrease. This may indicate an early shutdown of the upper stage engine. We'll stand by. This may indicate an early shutdown of the upper stage engine. We'll stand by. We're now about a minute past the expected time that we expected to see the cutoff. We're now about a minute past the expected time that we expected to see the cutoff of the upper stage engine. Silent. There was, however, an apparent loss of attitude control from Astra have gone silent. There was visually speaking apparent loss of attitude control. At least visually speaking, it appeared to be a loss of attitude control. And then we saw the telemetry from an onboard camera velocity meter start to decrease. And then we saw the telemetry indicating that there may velocity have been a problem with the start upper stage performance, the upper stage part of the mission. There may have been a problem with the upper stage Astra on exactly what happened. Part of the mission. So we'll stand by for a word from Astra on exactly what happened. Astra has confirmed that today's mission did fail during the upper stage burn. The engine shut down a little bit early, about a minute earlier than planned, and the two TROPICS satellites on board were about a minute earlier than planned, and the two TROPICS satellites on board were not able to be delivered to orbit today. Now 14.5 minutes since the launch of Astra's Rocket 3.3 vehicle. Now 14.5 minutes since the launch of Astra's Rocket 3.3
Astra has confirmed again that the mission was not successful. The two TROPICS
Astra has confirmed again
satellites
that the mission
that were destined to study hurricanes from orbit.
TROPICS
research satellites
orbit
that were
as
destined
planned.
to study hurricanes.
This was
from
due to
orbit.
an early shutdown of the upper stage engine. That shutdown appeared to occur
This was
about
due
a
to an
minute
early shutdown
before the scheduled time. That shutdown appeared to occur about a minute before the scheduled
at that time.
The rocket was not traveling fast enough to reach orbital velocity.
At that time,
the
rocket
was not traveling fast enough to reach orbital velocity.
Research satellites were expected
the upper stage and the
re-enter the
atmosphere. They were already in space.
Research satellites were expected to
re-enter the atmosphere.
They were already in space
crash
at that
and
point.
burn up, likely in the
expected to
atmosphere.
re-enter the atmosphere and
somewhere over the Atlantic
crash
Ocean,
and burn
east
up,
of Florida,
likely in the atmosphere,
likely
a few
somewhere
hundred
over
miles
the Atlantic
downrange
Ocean,
at
east
least.
of Florida.
At the time of the failure,
a few hundred miles
upper stage was at an
downrange
altitude of about 300
At
miles.
the time of the failure,
the
upper stage was at an altitude
faster
of
than
300
6
miles
or
or
500
500
kilometers,
and traveling
but that's
at
not
the
quite
speed
faster
faster
than
than
6
6
kilometers
kilometers
per
per
second
second around the Earth.
But that's not quite fast
these
enough
two
to
satellites,
achieve a stable orbit
around
the
the
Earth.
are now re-entering the
these
atmosphere
two
likely
satellites
and will burn up
and be
and
destroyed.
are now re-entering the
This
atmosphere likely and will
was
burn up
Astra's
and be
7th orbital
destroyed.
launch attempt, and
This
the company is now
was
2 for
Astra's
7. 2 of
orbital
those
launch
missions have
attempt,
actually
and,
successfully reached
the
orbit.
company
out of
is
those
now
7
2 for
attempts.
7.
2 of those missions have actually
NASA does have 4 more TROPICS
TROPICS
hurricane research satellites built. And
NASA does have 4 more TROPICS
two future
hurricane
Astra
research
rocket
satellites
flights
built.
and
Those missions were scheduled to occur in late June
future
and
Astra
mid-July.
rocket flights,
But we'll
those
see if
missions
those
were
schedules
scheduled
hold
to
now
occur in
after
late June and
Astra's
mid-July.
encountered another
But
launch
we'll
failure.
see if those schedules
They may
hold
need
now
some
after
time to analyze
Astra's
the data
encountered
and
another
introduce
launch
and
failure.
institute some
They
corrective
may need
actions
some
before
time
their
to
next
analyze
flight.
the data and introduce and institute some corrective
So with
actions
that,
before
we
their
thank
next
you for
flight.
joining us for our live coverage today.
So
from
with that,
Cape Canaveral,
we thank you
Florida.
for joining us for our live coverage
We'll have
today.
further live
from
coverage
Cape
of
Canaveral,
launches
Florida.
later this week. There are 2 SpaceX
We'll have
missions
further live
scheduled
coverage
to
of
launch
launches
from Cape
later
Canaveral
this
in the
week.
next
There are
week
2
from
SpaceX
PAD-40
missions
at Cape Canaveral
scheduled
Space Force
to launch
Station,
from
as well as
Cape Canaveral
PAD-30
in the next week
9A
from the
Kennedy
PAD-40
Space Center
at Cape Canaveral Space Force Station.
So
as well
those
as
are the next
PAD-30
launches that we'll be
9A
covering live
Kennedy
here in
Space
Florida.
Center.
We'll hope you
So
will
those
join
are the
us
next
for
launches
those
that we'll be covering live
and
here
until
in
then,
Florida.
I'm Stephen
We'll
Clark
hope
from
you
SpaceflightNow.com.
will join us for those.
Have a good afternoon. And until then, I'm Stephen Clark from SpaceflightNow.com. Have a good afternoon.
Propulsion continues to be normal.
RCPA chamber pressure looks good. Doubling up. Roger, roll with Atlantic.
Water towers can fly! Yes!
Echo Delta nominal.
Flight is outside SCE off. Say again, SCE off. Yikes. You bet. Concur. We don't need any more of these.
Ai, gente, vocês não sabem a correria que é. Mal cheguei, já tô saindo de novo. Aí, pra agilizar, é só buscar por voz aquela receita vegana rápida. E quando você não sabe se a sua planta tá se afogando ou é só tímida, o jeito é apontar a câmera pra ela pra saber o que fazer. Aí chega no fim do dia, você vai fazer o seu skincare. Que é esse tal de ácido hialurônico? Por voz ou por câmera, é só buscar com o Google. Suas definições de busca foram atualizadas. Descubra no Google.
Conheça o óculos inteligente utilizado pelo exército americano que chegou ao Brasil por preço de banana. Com a tecnologia patenteada, o Ultravision é capaz de aumentar drasticamente a clareza visual, mudar de cor automaticamente em diferentes condições climáticas, aumentar o foco em 7 vezes e eliminar qualquer tipo de reflexo, fazendo até você enxergar através da água. Confira alguns dos benefícios. Lentes fotocromáticas. Com elas, quanto mais forte for a luz do sol ao ar livre, mais escuros serão os óculos de sol, evitando as dores de cabeça causadas pela fadiga ocular. Lentes polarizadas, com tecnologia que garante o filtro de qualquer tipo de reflexo, garantindo cores mais vivas em alta definição. Bloqueio 100% UV, capaz de proteger o olho humano contra 100% dos efeitos nocivos dos raios solares. Ultra resistente, seu material de alta tecnologia de alumínio e magnésio é leve e extremamente durável. Confortável de usar, sua flexibilidade traz leveza e adaptação a todos os rostos. Essa tecnologia foi aprovada por mais de 20 mil pessoas por todo o mundo e essa é a sua chance de ter o seu. Compre agora por R$ 9,68 ao mês e teste por 30 dias. Se não gostar, devolvemos o seu dinheiro. É a sua chance de obter a tecnologia do exército mais poderoso do mundo. Promoção válida somente através deste vídeo. Clique no botão azul e seu desconto será aplicado.
And welcome back to NASA Spaceflight's live coverage of the SLS rollout. This evening, we are joined by Mr. Chris Gebhardt. How are you doing, Mr. Chris?
I am doing well. I've relocated south of my house, and I'm now staring at a very happy building. Yes.
It is the happiest of all buildings. And give me a 5x5 in the chat if y'all can hear us. Obviously, start asking questions and whatnot as well, and we'll get those queued up to do a Q&A as we go through. And also, you're in the field, Chris, and also in the field we have Miss Julia Bergenon. How are you?
Well, good evening. I am quite well, enjoying this lovely evening out here at Kennedy Space Center, right in front of the VAB, with a wonderful view of what's about to happen.
I sure hope it's a wonderful view. And also pushing buttons today, we have Michael Baylor. Thank you, Michael, for your help pushing the buttons. And also, Mr. Philip Sloss is joining us again. Thank you for coming back for round 2, Philip, because Chris, Philip, and I were on NSF Live earlier, and Philip has not been too burdened with my presence. So thank you so much for coming back, Phillips.
Yeah, no problem. Only I wish I was out there, but at least we can watch it live.
Hey, that's what these live streams are about. And also out in the field, we have Mr. Stephen Mars going to be taking some beautiful photos and probably posting them up. So if you want to check out what he's up to, definitely take a look at his Twitter at SpaceGhostSteve on Twitter. And that is it. So currently, Chris, what are we looking at? I'm seeing some people, some structures, some yellow things, some big things. I even see like part of a crawler wheel. What are we looking at here? Oh, maybe Chris fell off here.
Talking while muted. Talking while muted.
Oh, there we go.
First,
Okay.
I want to direct your attention to the right-hand side about center. There is a person standing on a yellow pedestal looking up at a gray thing. So the yellow pedestal is the foot that the mobile launcher rests on when it's inside the vehicle assembly building. The gray part is the mobile launcher, and you can actually kind of see that it might be starting to lift. It might still be flushed down, but we're going to see that gray part lift away from the yellow part, which is why we went live right now. They're not rolling yet, but they're getting ready to roll. And the first step of rolling is to actually lift it off the pedestal, and I do believe I see daylight between the gray part and the yellow part, which means the lift is indeed happening. So the crawler it's a term called jacking. So it basically lifts the mobile launcher up off of those pedestals. And then that's how the mobile launcher can clear the ground pedestals when the crawler starts to move. So we went live right at the right time to be able to show you that, because the lift off the pedestals is the first part of the roll maneuver. So that means that they just started lifting. So we are about 15 to 20-ish minutes away from first roll motion. that sort of matches what happened back in March, the first time they rolled SLS out to the launch pad, and pretty much matches the operations that happened during the shuttle and Apollo eras as well, with the mobile launchers, mobile launch platforms, and the crawlers. So all in all, we went live right at the right moment there, and you can see that guy, that spotter, taking measurements now to know exactly how much it is being lifted. There are 4 other spotters for the 4 other pedestals that exist there that are all doing the same thing, making sure that the jacking of the mobile launcher off of those pedestals is all uniform, and that mobile launcher deck is being kept perfectly level as it lifts it off. And it's a big job to keep something that massive totally level as you are moving it. And I'm sure there's going to be many, many questions about the crawler and how it does this. And I don't just want to go into a diatribe about how it does, because I'm sure there are going to be questions. And I know you all like hearing your questions asked on air, but very glad that we were able to go live right in time to show you this procedure to lift it up off of the yellow ground pedestals here.
Absolutely. I don't think we could have planned that timing any better. Jared is actually asking a very timely question here. He asks, how is the lifting done? Is it done with hydraulic pistons or worm drives? Do any of y'all know that?
I believe it's hydraulics. It's, it is there are crawler systems, and of course the other thing we should point out is there's essentially a not identical, but I mean you have a set of pedestals out at the launch pad that the mobile launchers, the mobile launcher platforms during the shuttle, and the mobile launchers for Apollo, Saturn, and for SLS we talk about hard down at the pad. That'll be the end of the operation for the ML. At the end of this, they'll position it over the pedestals of the pad and lower it down onto the pedestals there, and then the crawler will back out at the end of this, hopefully later this morning. And so it has these things called, I think they're called, what is it, jacking and equalization.
Jacking, leveling, and equalization.
Right. And so, yeah, I believe it's hydraulics.
Yeah, and there are actually it's not one jacking and leveling system. It's actually 4 independent jacking and leveling systems. So each massive wheel tread that the crawler has, we'll talk about all those distinctions too as the evening progresses. But basically, at each of the 4 corners of the crawler, there is a jacking and leveling system. So that way, if you're going over uneven terrain, the other side can keep it level. And when it gets to the pad and it has to climb the 5% grade, the 5% incline, it can keep everything absolutely perfectly level. So 4 independent jacking and leveling systems is what is used to actually do the operation you are seeing here right now, which is to lift it off of the pedestals right now.
And you can see that the mobile launcher, they have, I guess, what you might call guide pins that you can see that extend out from the bottom of those corners there.
Yeah, and it's also important to note too, because I think a lot of people might think, oh, like it gets out to the pad and it gets to these pedestals and it gets bolted down, right? Like it gets bolted to the pad. It does not. It is the sheer physical weight of everything that keeps it there. They do not bolt it to anything.
That's crazy.
Yeah, I'll do you one more.
Go for it. Go for it.
I'll do
you
you
already
one
blew
more.
my mind there. Go for it.
There is no hold down system for the SLS rocket when it is actually in launch configuration. The only time there are bolts actually holding the rocket to the so when I just said about that they don't bolt the mobile launcher to the pad, they also do not bolt the SLS to the launch pad unless it is for roll operations. So there are bolts with nuts and everything on there holding the solid rocket boosters down to the mobile launcher deck. There are 4 hold down bolts for each solid rocket, but those hold down bolts are actually removed once they get to the launch pad and while they would get into launch operations. And there's just a guide pin with no bolt, nothing holding it down. It is just the sheer weight and mass of SLS that will hold it down to the launch pad as the 4 main engines on the core stage ignite. And then once the solid, because they cannot lift that vehicle, they cannot move it. So the guide pins just keep it aligned to keep it from jumping around from side to side. But there's nothing that holds it down. So once those solids light, bang, up you go. There are no pyrotechnics to release, no possibility of a hang up, no possibility of the vehicle having to catastrophically rip itself from the launch pad. Much simpler design for SLS over shuttle.
That is absolutely crazy. My goodness, just letting it sit there.
Yeah.
Wow.
They still have to get the umbilicals away, but they don't.
Yep.
Like Chris said, they don't use pyrotechnics to disconnect those anymore. The pyros are on the vehicle to separate the boosters from the core stage when the boosters are done, but that's not for vehicles moving a lot faster at that point and is a lot higher off the ground.
Yes.
Yes. I'd hope it would be a little higher off the ground.
Yeah.
Mark is actually asking another question here. He asks, what time is it going to arrive at the pad? Dude, is that all scheduled out? Are we pretty much holding to the schedule that we had heard earlier?
It is about 11 hours from first motion to hard down. And there can be some variation to that. The plan is to only stop once, which is they will come out of the vehicle assembly building fully, and then they will stop and they will rotate the crew access arm. They will pull it back from the Orion and they will pull it back to its fully retracted position. And then the plan is to go completely to the pad from there on. Now, sometimes you do have to... sometimes things overheat on the crawler. Sometimes you have to regrease things. Sometimes you might need to stop just to, check something here or there. But the ultimate goal is there's one planned stop and then out to the pad we go. So roughly 10 to 11 hours to get to pad B for SLS from first motion to hard down.
That's awesome. And thanks y'all for the chats and keeping the questions coming. We appreciate it. Musical Wolves had a super chat, so thank you, Musical Wolves, for the support. He asks, is there enough nighttime lights to run the cam feed using solar? How many wide dynamic ranges would temps I'm a photographer. That's not wide dynamic range. That's wet dress rehearsal. Welcome to SLS land. How many wet dress rehearsal attempts will SLS have before they decide to roll it back if needed?
The number of attempts. I think the intent is to however many it takes to complete the test. So obviously NASA would like that number to be 1. That would make it a total of 4. But they're certainly intending. I mean, just like last time, the intent was just to go out and execute the test. They just couldn't get the They could not complete the tanking part of the test, and that meant they couldn't complete the rest of it. But that's what the schedule is 2 weeks. Well, I guess it would be 13 days, and there may be a little bit of moving around on the schedule. They have a 14-day schedule approximately, and they have they've carved out 2 days of weather contingency there in case they get slowed down. Because now they're going to be outside, but they'll do the standard 2-day countdown. They just like they did last time. Hopefully the weather won't be quite so severe. I guess you could say that the summer pattern might be maybe a little bit less severe possibly than springtime. I don't know. They do get plenty of they get plenty of lightning and thunder and rain out there. But I think it's basically I think what they've said to us is they're going to make the next attempt and see where they get. And so as long as I guess another way of putting it is they made 3 attempts last time, and so assuming that there isn't a showstopper that forces them to come back like there was last time, they'll it'll be like a launch campaign. They'll just keep fueling the vehicle until they get the countdown down to where they want to stop.
Yeah. And I think the other sort of side to that answer is sort of a larger question, but a little more nebulous, which is just, is there like a maximum amount of time that SLS can be outside of the vehicle assembly building and just outside and exposed to its various elements? And the basic answer to that is there is. NASA has not specifically stated what it is. It's kind of a moving target, and the biggest consideration is actually the wind loads that are placed onto the stack. But they noted when they were getting ready to come back from the pad back in late April, they noted in a press conference to the media that even though there is that sort of limit that's out there, they are nowhere near it. So it's not like, oh my God, there's a ticking clock and then it has to come back. They can more or less keep it out there as long as they need to complete the test. The major things we would be looking at for potential rollbacks that wouldn't have anything to do with the technology or the pad systems would be, we are in June, we are in hurricane season. So if a tropical system were to form and start to threaten the Cape, they would want to pull SLS from the pad and bring it back to the vehicle assembly building. And exactly what its considerations are there, I have not heard them discuss just yet. And I would caution I would caution anyone on using the space shuttle as a sort of determiner or place to start with that, because the major thing you would be concerned about with the shuttle would be protecting the orbiter, and they had a big rotating service structure. So unless it was actually going to be a hurricane strength storm, like 73 mile per hour winds or greater on the hurricane scale, they could leave the vehicle out there for shuttle. I don't know if that's the same for SLS, since there is no structure out there to wrap around it to protect it. So a significantly weaker storm than we were used to with the previous program could force them to come back. But that's sort of the major weather thing that they would be looking at here. And, it's June. These things can pop up with about a week's notice or less. So it is entirely possible that yes, like a tropical system could get them and they'd have to come back. But that would be just to protect the vehicle, not for any other reason than that.
Interesting.
Right, and one of the things that we talked about during NSF Live this earlier today was if they had not had this issue with the gaseous nitrogen supply from offsite, they may very well have stayed out at the pad in April and tried to finish the sort of abbreviated test that they'd set up to do on the third attempt without the ICPS. And so for example, they're talking about this hydrogen leak that they've addressed as best they can. If it turns out that they still have something that they need to take a look at, they could bring all the scaffolding out and take a look at. That's one of the few things they could take a look at while they're out there.
Yeah, that leak coming in a very fortuitous spot at one of the tail service masts at the base of the vehicle, at the base of the ML and at the base of the core stage. It does provide a level of access. Like you were saying, the original plan, even after they discovered the liquid hydrogen leak, the original plan was to fix it out at the launch pad. So yeah, if they were to encounter something like that, they could opt to try and fix it, which, in all honesty, fixing something like a hydrogen leak out at the launch pad makes a lot more sense, because you really can't test a fix for a hydrogen leak until you introduce hydrogen into the system. Because hydrogen is very, 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 very small when it's very, very cold at its cryogenic temperatures, which causes things to contract and seals to change. So it's actually better to try to fix a hydrogen leak issue out at the pad, because you can test the fix with cryogenics out at the pad, where you can't do that in the vehicle assembly building.
Right, and it just wants to. Liquid hydrogen is really good.
They're moving. First motion has occurred. They are moving off the pedestal. The spotter has gotten away from that. So that is first motion of SLS out to the launch pad.
Yeah, that's improvement from March. Only 15 minutes late.
yeah, and that means they got basically 15, 20 minutes is how long it took them once they started lifting it and jacking it off of the pedestals here. So Yeah, here she comes. Yeah.
Looks like
this
some
is
excited people in the foreground.
Oh, indeed, and probably here in a little bit we'll zoom out just a little bit so you can see it moving against the scaffolding, and then the other camera that we have deployed should see it. Should have the glory shot of it emerging from the VAB here momentarily. But yeah, so at basically 12:16, they were on their way to the launch pad.
Wow.
Okay, you can do that.
So mesmerizing to watch those big crawler tracks move.
Yeah, and we'll definitely zoom out on this view in a minute, but it is cool just to watch the treads of the crawlers start to churn and move this behemoth out of the vehicle assembly building. While it doesn't look like it has moved all that far, because it hasn't, the back end of it is actually sticking out of the vehicle assembly building now, which is pretty cool.
A vida pede uma TV com beleza em cada detalhe. Pede Samsung Neo QLED 8K na Casas Bahia. Pede agora com até 30% de desconto em até 10 vezes sem juros.
É de Casas Bahia.
Do you want to get a little wider shot there, Steven, just on the camera so they can see sort of the larger structure of the ML, and then we can zoom back in on the base. This is a view from our other deployed camera here, which should give you a nice sight-on view as the vehicle begins to emerge here. But yeah, the crawler doesn't move fast, but when you've got a building to compare it to, you've got a good indication of how fast it actually moves for something this tall and this massive. I mean, it's honestly kind of impressive that they can go half a mile an hour as their speed with this thing on it.
They're literally moving a building. Is there a maximum number of times that the core stage tanks can be pressurized or unpressurized? Sam is asking that question here in the chat.
Yes, there is. So I believe they budgeted about 12 pressurization and cryo cycles for for the testing campaign. So that would include the fuelings of the core stage for the green run, the fuelings of it for the wet dress rehearsal. But the number of times that they will fuel this and put this through its various paces doesn't really come close to its total potential life cycle. They did upgrade that particular element from the shuttle external tank to the core stage for SLS. It can be fueled many more times and pressurized many more times than the shuttle tanks could. And that's mainly because the shuttle tanks were not designed to undergo these sorts of test campaigns that SLS's first core stage has had to do for the program. And the original idea for the core stages is that all of them would actually go to the Michoud, would go from the Michoud assembly facility to Stennis for a fueling and test firing before coming to the Kennedy Space Center. That has now been scrapped, and only the core stage that we will be seeing here momentarily is the one that will go to Stennis and do all of those tests. So all of the others will not be put through the same sort of hot fire test that this core stage was. But because that was the original idea, they had to design the overall lifetime thermal and cryogenic cycling loads that the core stage could withstand with that in mind. So actually, it's just a bonus now when they get here, because now you have more attempts to launch them, but you're never really gonna get close to that number.
Okay, interesting.
If that makes sense.
It was I mean, it was something like a little bit over 20, but again, it depends on how you count. So just as an example, in April, they never really completely got through a full tanking cycle. So how do you count that? I mean, if you want to just count full cycles, they did 3 of them at Stennis, and so that would leave them with something close to 20 cycles. And so, like Chris said, it's pretty unlikely that they'll use up much more of that.
Indeed.
Well, another question from Cethia, it looks like. They ask, you mentioned a little bit ago, Chris, about hydrogen being one of the smaller molecules and very difficult to contain. How do they actually do that? I mean, it doesn't just seep through all of the materials you throw at it. Like, how does that work?
You would think so. Yeah. So hydrogen and helium are the 2 smallest molecules. So they love to leak because it's very easy for them to leak. But no, I mean, basically, you can design systems, you can design materials, you can design the seals that are used to basically counter for that, right? Like when you have a particle that leaks like that, you can design systems that that do not leak to the extent that you're going to breach a safety limit, right? Now, when we sort of talk about leaks, something that is good to remember is that no system is perfect, and you do not design a rocket system that uses hydrogen to not be able to launch when there is hydrogen in the ambient air around you, right? I mean, just in Earth's atmosphere, that's impossible, right? I mean, you're going to have hydrogen at some point. But the good thing is that hydrogen, because it only has 1 electron, it loves to bond with something else. So it usually is not in its free, unstable state for very long because it likes to find other things to go bond to that then, reduce its sort of that reduce its potential, right, to bond with other elements. Chemistry 101, yay everyone. But some of it does leak, right? Some of it does leak out of the tail surface mass. It leaks out of the gaseous hydrogen vents. And that's why there are acceptable limits. It's counted in parts per million, but there is an acceptable part per million count of ambient hydrogen in the atmosphere around the vehicle. And that's why everything is so very heavily censored and monitored so that you really, really know what's there. Because at a certain level, hydrogen around your vehicle is not an unsafe condition if it's in a low enough state where it either won't ignite or when it does ignite, it's not going to be a whoosh like you see with the Delta IV, right? We do not want a whoosh of a Delta IV igniting the ambient hydrogen around it. So like at main engine start for SLS, you will see the hydrogen that's still in the air around the engines ignite and sort of flame out really, really quickly. If you go look at some old shuttle engine ignition sequences, you can see what I'm talking about there. So basically, you design the system so that it won't leak majorly, but you can't stop the gaseous stuff from just leaking out. It's going to happen. So what you're trying to really do is mitigate how much of that is getting out. And you basically just over-design your system so that you don't breach the part per million count of hydrogen that's available. And I'm going to use 2 examples from the shuttle program, not because I'm a shuttle file, but because
Wait, you like the shuttle?
I kind of do. But because
I am.
But because it's the system that this is directly derived from, right? And it is the system of which we can look back to get answers to. So if you go back to STS-93, when Columbia was launching the Chandra X-ray Observatory, the first attempt to launch that mission ended at T-minus 7 seconds at the time. There was 1 sensor on the mobile launch platform that registered hydrogen spiking above its part per million count. All the other sensors showed this was not happening. The bias in the system is that if 1 sensor tells you something is going amiss with hydrogen, you listen to the 1 sensor that is telling you something is going awry. Even if that sensor is faulty and all the others are telling you it's fine, you stop when that 1 sensor breaches its limit because you want to be absolutely sure. So 1 sensor breached, they stopped. It wasn't a real thing. They redid the sensors and launched 2 days later and everything was fine. Later on in the program, they had issues with what was called the ground umbilical carrier plate, which was what which was the ground side of the system that vented the hydrogen out of the tank when it boiled off into its gaseous form during the countdown. And basically what happened is the orange rocket emerges from the vehicle assembly building here from our vantage point is that was a real leak. And all of the sensors showed it. And what happened on that one is you